we go to my grandma's house, she'll be partying.
His grandma's like throws ragers every weekend.
Yeah.
Yeah.
What?
All right, I think this is
She's
up.
got like 8
I'm not sure.
Doing.
If not, I'll upload this video. All right, so like I said, yeah, made a mistake on page 3, counterclockwise, clockwise, from my perspective versus yours. My bad. Let's talk about this. So, translations. We translate by vector. So let's look at number 2. Here's number 2 going from C to C prime. Remember, direction matters. That's the vector. That's the direction we're heading in. We're on number 2. Let's go. We are on number 2 because I'm skipping other ones. I don't ever do every single one in the packet. I chose number 2 because number 1 is simpler. So it looks like we're going 1, 2, 3, 4, 5, 6, 7, 8 to the 9 to the right. So that means we have a rule of plus 9 in the x direction. And then it looks like we're also heading 1, 2, 3 up, so plus 3 in the y direction. That is our rule. So if we write down our coordinates for A, B, C, D, we can find A prime, B prime, C prime, and D prime without having to count them all, which will save us some time, which will be nice. A is at negative 1, 2, 3, 4, 5, 6, 7, 8. And down 1, 2, 3, 4, 5. So if we apply our rule, we add 9 to the x and add 3 to the y, we get an A prime coordinate of 1, negative 2. Which if you check, 1 comma negative 2 is where A prime is. Now you do the same for all your points. So you have 2 ways of figuring this out. 1, figure it out looking at the diagram and find your rule, and then apply it to all your coordinates.
Yes.
Or write down all your coordinates, which takes way more time, but then you'll be able to see exactly what's going on. And then you can write your rule. From here to here, I added 9, and from here to here, I added 3, right? That's the rule. How do we feel about translations?
Easy.
Adding and subtracting, sliding stuff with a vector. Cool, 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 cool. All right, next page. Yes, yes, yes. If you keep saying it, one of these times it will be funny. All right, number 4. I know, isn't it great? All right, so we're going to flip this over this line. Now, before I gave you the reflection, right, I showed you what happened. I didn't need to do that. There's a little bit of training wheels, right? We can see what's going on here because we know reflections work this way. If I look in the mirror, mirror me is the same distance from the mirror as I am from the mirror. So if we look here, the distance to the mirror from B is 5. So it should be the same distance on the other side. That's what's nice about flipping across a perfectly horizontal or perfectly vertical line. It's really easy to see where these reflections are. Much easier than what we did last week with our quiz, right, where we had to find the perpendicular and all this stuff, right? This, we can just see where the perpendicular is, and we can find the midpoint and then double it, right? So we flip it across here, 5, 1, 2, 3, 4, 5. Of course, it's minus now because we're going down. And that's where B prime is going to be. Same thing with A prime. It's going to be the same distance. That's also a distance of minus 5. And if we connect those, there's our reflection. So we can write those points down. Our original points are, for B, looks like 1, 2, 3, 4, 5 to the right. Whoops, that's B. 5 to the right and 5 up. For B prime, it's 5 to the right and 5 down. You can kind of already see the pattern here. A appears to be negative 1 up 5. A prime is also negative 1, but down 5. So you can see from those coordinates what's going on. What's our rule going to be? Yep, x, because x stays the same, right? Negative 1 stays negative 1, 5 stays 5. And then y changes. How does y change, Xavier? Say it again. Right, it changes its sign. So it goes from positive to negative. So we change the sign. Remember, to negate, which is what I'm doing here, with that minus sign, doesn't mean to make it negative. It means to change the sign. If those 5s were already negative, what would happen after I negate them? I'll say it again. If those 5s over here were already negative, what would happen after I negate them? They become positive, right? Negate means change the sign. Nothing next to the x means keep the sign. See how it's negative here and stays negative? It doesn't turn positive because I just have a regular x there. It means keep what you got. This means change what you have. 5 times -1 is -5. Are we cool with that concept? It's a very common mistake to confuse negation with making it negative. Not the same thing. Cool. So when we flip over the x-axis, we make the y negative. Why is this? Because what kind of a flip are we doing here? A vertical or a horizontal flip? What way are we flipping this? Vertically or horizontally? We're flipping it vertically, up and down. So of course the y value changes. We change vertically, right? Did we change horizontally at all from here to here? No, we did not, right? We didn't move left or right any. We stayed the same. But we did flip vertically, so we're going to have a negative y here. We changed how we changed the vertical, right? From +5 to a -5. Cool with that? All right. Next one. Let's just look at this. When we flip it across here, we're flipping this way. Is that a horizontal or vertical flip? Horizontal flip. So are we going to change horizontally or vertically? We're changing horizontally. Which variable deals with horizontal? X. So the x is going to change. The y stays the same. Now, that is when we flip across the axes. Right? If I move this a little to the right or a little to the left, it's going to change it, but the same principle is going to apply. So there's the rule for number 5. I'll leave the rest for you. Let's look at number 6, which is the same dumb thing. It's just we're not flipping right over the y-axis, right? We're flipping over a vertical line, but it isn't the y-axis. Do you guys see the y-axis is separate from the vertical line here? Okay, cool. So it's going to be very similar. I'm going to break this down into 2 steps. So we start off with x, y, and then we do our flip. So we know to flip across a vertical line, we negate the x, change the y, because we're flipping this way, right? We're flipping horizontally. So we're going to change horizontally. But that's not going to get us the right coordinates. If you look at b, it's -2, 1. b prime isn't going to be at 2, +1, right? It's going to be flipping between here and here, because these are 3 on each side. So that's not going to get us the right coordinates. So we're going to have to figure out what happens here. So b is right here. It's 3 away from our line of reflection. Does everybody see that? Now, it should be 3 away from the line of reflection when we flip it. So 1, 2, 3. It just so happens to be where C used to be. So that's where B prime is going to be. Same thing for C. C is 3 away from the line of reflection. So it's going to end up 3 away on the other side of the line of reflection. Again, from the line of reflection, 1, 2, 3. So it's going to trade spots with B. It's because they're both the same distance from the line of reflection. If I had something like this, where here's my line of reflection, and here's my shape, here's B, here's C. B is 2 away from the line of reflection. So when I flip it, it's going to end up here, B prime. Didn't change spots with C. That's because it's only 2 away. C, on the other hand, is 1, 2, 3, 4, 5, 6, 7, 8 away from the line of reflection. So it's going to be 8 away on this side. 1, 2, 3, 4, 5, 6, 7, 8. So there's C prime. And so when we flip it, it's going to look like this. Do you see that? Okay. So this is just a coincidence that they end up trading spots. It's because they're both the same distance from the line of reflection. Everybody dig that? Cool. All right. When we write these coordinates down, B is at -2. Again, we're counting from the axis now, right? To figure out its coordinate, make sure you count from the y-axis. 2 to the left and 1 up. Is everybody cool with how I got -2, 1? Common mistake is to count from this big thick line, but that's not our axis, right? That's the line of reflection. Make sure you count from the origin. Start at 0, 0, 2 to the left, 1 up. Everybody cool with that? Okay, common mistake is to count from here and say -3, 1. B prime, again, counting from the origin, B prime is 1, 2, 3, 4 to the right and 1 up. Did anybody accidentally count from the line of reflection? Yeah, it'll happen, right? Don't let it happen to you. Know your tendencies. All right. Let's take a look at these points right here and try to figure out what the rule is. Looks like we keep the y, right? But something crazy happens to the x. Maybe we add 6. Maybe we times by -2. right? We got some options here. To figure out better, we need to look at other points. So let's look at C. C starts out at 1, 2, oh, sorry, I counted from the line of reflection. 1, 2, 3, 4, comma 1. And goes to C prime, which is negative 2, comma 1. Sorry. So it does look like we keep the y. That seems to work, right? And that makes sense because we're flipping horizontally. The y is not going to change. But multiplying by negative 2 isn't going to get me negative 2 here. It's going to get me 4 here, but it's not going to get me negative 2 here. It's going to get me negative 8, right? So that doesn't work. Adding 6 also doesn't get me here to here. So neither of those work. What's really going on here is first we flip it and we negate the x. And then we do something. So there's an intermediate step. If I negate the negative 2, what does it become? 2. What do I add to 2 to get to 4? So I add 2. So I negate the x, and then I add 2 is what it looks like. So I'm going to do that, and then I'm going to add 2. If I negate the 4, what do I get? Negative 4. Then add 2. I get negative 2. So the rule is really this. It's negate the x, because that's what kind of a flip we're doing. We're doing a horizontal flip. And then we're going to add 2. Keep the y. Do you see it? The question is, why is that the rule? We'll get to that in a second. But that's how we figure out the rule, right? We apply our flip just like we normally would, negate the x, and then ask ourselves, how do we get there? Well, we add 2. Let's check that out. If you look at A has the coordinates negative 2, comma 1, 2, 3, 4, 5. Again, make sure you're counting from the origin. A prime, on the other hand, it's going to be 3 away from the line of reflection, so it's going to switch spots with D. So A prime is going to be over here. A prime, on the other hand, is 1, 2, 3, 4. Again, start from the origin. And then up 1, 2, 3, 4, 5. Our rule, supposedly, is that we're negating the x and adding 2. If we negate negative 2, what do we get? 2. Add 2. Do we get 4? Awesome. So our step 1 is to negate the x. And that is our flip, right? Our flip horizontally, negate the x, change horizontally. And then from there, we're adding 2, which is really applying a vector of 2, 0, right? When we add 2, isn't that like adding 2 to the x value? So that's a vector. Smell what I'm stepping? It's like a translation from the first page. So we're flipping it and then sliding it. Why is that? Here's why. Take a look at D. If I flip D over this, the axis, it's 1, 2, 3, 4 away from the axis, right? And if I flip it 4 away from the axis, it ends up over here. Here's 4 in this direction. From the axis, 1, 2, 3, 4. So D prime would end up there if I flipped it over the axis. D prime is supposed to actually end up here, right? Because we're flipping it over this line. How far away is D prime from the real D prime? 2. That's where the slide of 2 comes in. This plus 2 that we do right there, it slides it to where it needs to be. So what we're really doing is step 1, we're flipping it as if we were going to flip it over the regular axis, right? The easy flip. And then afterwards, we're adjusting for that. Do you see how that works? That's kind of interesting. So we flip it as if it was going over the axis, just like this one, right? Easy flip, negate one of the values, right? But that's not really what we're doing. We want everything slid over, right? Ends up we need to slide it over 2 to make up for that. And that's where that plus 2 comes in. So how did I figure it out? Well, I know I'm doing a horizontal flip, so I'm going to change the x, right? And then I ask myself, after I change the x, what do I need to get here? Well, I need to add 2. That's how I figured out the rule. You could also do what I did and say, I'm just going to flip it over this guy, and then I'm going to adjust for where it needs to be. Add 2. Flip it over this guy, and then add 2. Same thing. Are you smelling what I'm stepping in?
Yes.
This is a little bit different than what we did last time. Remember I gave you that weird one that I said was self-development? Yes. Right? I said I give you as self-development. Anybody might have figured that out. I think you worked on it for a little bit, right? But here's the idea. That's what's going on here.
Why's your hair wet?
How do we feel about this?
Better.
Mr. Knight gets a haircut.
I know. Bare hands, how do you feel? Yeah, for real? Nancy?
I feel like I'm gonna get a solid B on this test.
Sick. Coda? Xavier, how you feel? I got one. All right. We're flipping horizontally, yeah? Xavier, I'm talking to you. We're flipping horizontally. No. We're flipping horizontally, just like this one, right? That's going to change from here to here. Right? That changes the x value. Doesn't change anything about the y value. That's why we have this. We cool with that? Same thing down here. We're flipping horizontally, so it's going to negate the x value. But it's not flipping right across the axis. It's flipping across something that's a little bit over from the axis, right? So I negate it, just like I normally would, right? But we're not quite there yet. So what do I need to do to make it finalized? Well, I need to add 2. So that's the whole rule. Negate it and then add 2. Feel better? I'll take better. All right. That's reflections. You're going to have negation going on. You might have a little bit of a slide going on as well if the axis isn't the reflection. A line of reflection. Let's turn the page. Now we're on to rotations about the origins. This is back to what we were doing on Thursday of last week, not Friday. So not the homework, but very similar, right? Let's take a look at number 7. So I draw my L between the rotation, center of rotation, and the point I'm going to rotate. I always do the horizontal part first. You could do vertical then horizontal. Have an L that looks like this. I prefer not to. So I'm going to rotate that L. It says 180 degrees. If I rotate 180, does it matter if I go clockwise or counterclockwise? No, that's why it doesn't specify. So here I go. This is going to be easy. I can't screw this up. R to our blue line, right, is facing this way. Our blue line is pointing this way, to your left. If I rotate it 180, here's 90. Here's 90 again. Which way is it going to point now? To the right, to the right. So I start from R, and I'm going to do that blue line, which is 6 in length. And instead of going to left, I'm going to go to the right. And I'm going to go to the right 6, the same amount. The length does not change. Now I focus on just the red part. Look at just the red part. The red part pointing up or down? Up. If I rotate that 180, here's 90. Here's 90 again. Which way is the red part going to point after I'm done? Down. So I know it's still attached to the blue line. It's somewhere at the end of it. The question is, do I go up or down from there? And we just figured out we go down. So 3 down. And that's where B prime is going to end up. And that looks like a 180 degree rotation. Let's figure out this rule. B starts out at -6, +3. And B prime ends up at +6, -3. How would you describe this change? Change the x, change the y. And change in what way?
Negate.
Negate. Change the sign, right? So what was -6 becomes +6, so we negated the x. Right? Negative times a negative is positive. And then 3 becomes -3. Again, we negate the y. This is essential. This is a great example of how negating something doesn't always make it negative, right? We negated the -6 and it became positive. Negative just means change the sign. That's all it ever meant. I don't know why they didn't teach you that. When you plug in something for -x, it just changes its sign. If you plug in -2 for -x, you get +2, right? If you plug in -6 for -x, you get +6. That's the rule. Why is that the rule? Because it works. Look over here. Why is that the rule? Yeah.
Well, I don't know like the name of the like areas.
Quadrants?
Yeah.
Yeah.
The quadrants, but like when you go down and right, well, go right and down, the x would turn into a positive, and the y would go positive and negative.
Sure. A couple ways to think about this. Okay? Words are hard, math is easy. Over here. Okay? See this part over here, Alex? Horizontal or vertical? Horizontal. X or y then? X or y is that? What's this going to be? It's going to be an x, right? And it's negative because it's going to the left. Horizontal or vertical? I know, you're leading me through it. Y. Positive or negative?
Or positive.
There you go. Now when we rotate it, that blue part right there, still an X, 'cause it's still horizontal, right? But now it's going to be positive. And that Y, still Y, because it's up and down, is going to be negative, right? So the signs change. Another way to think of it is if I have a quadrant here, it's plus plus. Here is minus plus, and I know that because negative X, positive Y. Minus minus. Minus, plus minus. No matter where I start, if I start here, my point after I turn it 180, both signs change. We cool with that? No matter where I start, both signs are going to change. That's the rule. So you can apply that to the rest of the points and graph it, or you can graph it and then write down your points, whatever you want to do. It's up to you. How do we feel about that concept? Because things are going to get a little bit harder next step. We feeling good?
I think
Feeling great? Okay.
it's easier.
Here's where I made my mistake last time. Let's talk number 8. Let's actually talk number 9. Let's do number 9. Both are about the same. They both have their pluses and minuses. Ha 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 ha. All right. 90 degrees clockwise about R. So let's draw our L. I'm going to go to C first. Clockwise is what we're talking about. We're still live. Good. So look at that blue line going from R. Blue line's going to the left for you guys, correct? Correct? Okay, I'm good. All right. Correct? Okay, awesome. I'm going to turn it 90 degrees clockwise, which means counterclockwise for me. So clockwise for you is this way, the way a clock would go. So if I'm pointing to the left and I go 90 degrees clockwise, where am I pointing now?
To the right. You're pointing
Look at what I'm doing. I'm pointing to the left. 90 degrees clockwise gets me here. Where am I pointing now?
It's gonna be like this.
Up. Before we did 180, right? We're not doing 180 this time. We're doing 90. Here's 90 degrees.
Okay.
Right? So I was pointing left,
Yeah.
and now I'm pointing.
Up.
Thank you.
I thought you meant the.
So is that right?
Nope. Wait. I'm going to do it, and then you can check your work, and that's how you know if it's right or wrong. All right. So 1, 2, 3, 4, 5, 6, 7. 7 up, right? The reason I say that 8 isn't because it will be more efficient. I can do stuff with everybody, and then you can check yourself individually.
Okay.
Otherwise, I got to stop to check your thing while everybody else waits, right? When I can do 2 birds, 1 stone this way. So, whoops, sorry, that's not where C prime is. I got distracted. Eden. All right. I was going for perfect score this time, but I blew it. All right.
Come on.
Red line pointing up, correct? When I turn 90 degrees clockwise is this way.
Right.
Which way is it pointing now?
Right.
To the right. So the red line is still attached to the blue. The question is, does it go to the right or the left? And the answer was to the right, and it's going to go 3, just like it was before. So now we know where C prime is. Everybody cool with that? I apologize for that mistake. Are we good?
Come on, me.
Awesome. We're back on the rails.
Always gonna go ahead.
Regular C is -7, +3. C prime ended up at 3, 7. Not doing it on purpose this time. 3, 7. We cool with that? Awesome. I goofed up first hour by saying 7, 3, and no one corrected me on it. Yeah.
We're gonna get like the thing for over like Thanksgiving break.
The-
Like after this
What?
test.
Are we going to have to write reflections?
Yeah.
We're gonna do this after
Not a question that's relevant right now, but no. I mean, but yes, actually, yes, we will, because it'll be over last week too. Yes. So do it right after the quiz.
Why would you want to feel both?
All right. It's a reminder. So, what happened here? Somebody describe what happened here.
I think I know why.
Yeah.
You went from the -7 and you made it that, which is the x, you made it to the y.
Mhm,
So
mhm.
so the rule means y, -x.
Okay. So the x and the y changed spots. And then the -7, which was the x, became a +7. This one changed. Are we cool with that?
I'm confused now.
So both, you see how they switch spots?
Yeah.
Okay, so what was xy is now yx. They switched spots. The negative 7 became a positive 7. Do you see how this part changed? This was our original. This is our new. Which one changed? This one. Are we cool with that? I understand why you're confused. I get it, but that's what you got to focus on. That changed. Okay? It's because this represents that, and that represents this. Cool? All right. Why does this happen is what he kind of alluded to. Check out the blue part here. Horizontal or vertical? Which variable deals with that? X. So the blue part here is an x. And it's a negative x, but it's an x, right? Now when I rotate this 90 degrees, the blue part is no longer an x. It's a what? It's a y because it's vertical. So see how x became y?
Yes.
X became y.
Yes.
Are we cool with that?
Anytime you go 90 degrees, right?
Yes.
It's the word.
What about, because that'll always happen, yes.
One of the bugs.
And then the y became x. Are we cool with that idea? Awesome.
How many of these will be on the test? 1, 2.
Hopefully like 3.
180 and 190.
How do we feel about that idea? Cool, kosher, excellent, wonderful, fantastic. Let's look at number 8 really quickly. 2 things on 8 that are tricky. 1, the thing we just talked about, and 2, this thing. You might be thinking, how do I make an L between R and A? You don't, you just make a line. It's that easy. There's only a blue part, right? I rotate that blue part 90 degrees clockwise. Blue part's pointing this way to your right. If I turn it clockwise, clockwise for you guys is this way. So now it's going to point which direction? Down. So it's going to go down 4. And that's where A is, because we have no red part. So there's A prime. C shares the same leg as A does. It's just a little bit longer. So once again, it's pointing to the left. If I turn it 90 degrees clockwise, it's going to point down, right? But it's going to be 2 longer. And then the red part for C, because it does need a red part, is now pointing down. If I turn it 90 degrees clockwise, clockwise for you guys is this way. Which direction is it going to point now? Left. So C is going to point to the left. And here's C prime. Let's take a look at C and C prime's coordinates. Well, C is at 6, negative 2. Whoops.
Oh, gosh.
6, negative 2. And C prime is at negative 6, negative 2. I know what I'm doing. What happened here? What's the rule? Coda. Nailed it. C prime is not negative 6, negative 2. Very common mistake. It's negative 2, negative 6. We do the x part first. And you should have caught that because we know that when we do a 90-degree rotation, it's going to switch the x and the y. Look at this. The blue part was x before, but it's y after we're done. X and y change spots. So they should. So what really happened here? X and y changed spots. And then this one right here became a negative, right? 6 became negative 6. So what was originally our x became a negative version of that. Still feeling good about that? That's the thing that can trip people up. Again, look here. This is the one that changed, right? Not this guy. That was negative and negative. This is the one that changed. Feeling good? Question. 8 and 9. They have the same rule. Do we make a mistake? Why not? Zayden. That's right. They're both 90 degrees clockwise. First hour. Pay attention to that. They're both the same rotation. I also made the mistake that I thought one was clockwise and one was counterclockwise. They aren't. They're both clockwise. My bad. Again, it had to do with me mirroring all this stuff. So this is the correct answer.
I don't want to be the first time.
Yep. Normally I don't make that many mistakes in first hour. I really don't. They just don't get the most enthusiastic show with all the interesting tidbits. Today I made a mistake. I tried making a mistake on purpose like I did with you guys there. And then I got distracted and didn't come back to it. And then I compounded it even worse when I accidentally mirrored this the wrong way for them. Right? Yeah, that was my bad. Turning the page. Rotation about an arbitrary point. Same dumb crap, we're just moving the point. We talked about how to come up with this rule last week. We're going to review that today. That is going to be part of your quiz. So, from R, let's go to B. To the right. Danny, how was your Friday?
Terrible.
Yeah, wasn't it?
Yeah.
My Friday was great. Thanks for asking.
I didn't care.
So we're going from here to here. That is a lie. Every single class period, someone came in here and was talking about how much you were crying. All right. This from here to here. Are we cool going from R? It's the same dumb crap.
I gave Kaden $5 for.
Yeah, it was a waste of $5. 90 degrees counterclockwise. Counterclockwise is this direction. So we're swinging down. Think about it. R is pointing this way to your left. If I turn it 90 degrees counterclockwise, that's going to be here for you.
Yeah.
Which direction is it pointing now?
Down.
Downward. So that blue line is going to be down 1, 2, 3, 4, 5 from R. 1, 2, 3, 4, 5 buckets. So stopping there, I went a little too far. And then the red line is pointing up. It's 4 in length. Pointing up. We're turning it counterclockwise 90 degrees. Counterclockwise for you guys is this way. So which direction is it going to point now? To the left. So on the end of that blue line, we're going to go to the left. 4, because that's how long the red line was. And there is B prime.
Oh gosh, I did it again.
Now let's look at this rule. We're doing a 90-degree counterclockwise rotation. The X became a Y, and the red part, which was a Y, became an X. So we do have this flip of the variables, right? We do start out with a flip of the variables. That's going to happen. XY is going to switch to YX. But here's the problem. We're not rotating about the origin anymore, so this isn't going to cut it. We talked last week about what we have to do. What we have to do is we have to recenter back to the origin. We have to move everything back to here and then rotate from there. So what's the vector I have to use to get R to go back to the origin? What? 1 to the right and 1 up. So I need to apply a vector of 1, 1 to what I'm doing, right? That adds 1 to the X and the Y. So our rule is going to be start out with X, Y. We're going to add 1 to our X and our Y. Now that doesn't get the job done because we haven't rotated it yet. Rotation counterclockwise. We flip the X and the Y. So take all of that and flip it. Take all of that and flip it. X1 goes over, X plus 1 goes over here, Y plus 1 goes over there. Now we need to negate something. Check it out. When I go from this quadrant down to this quadrant, this is negative, positive. This is double negative. It's a big comma.
Yeah.
Second one changes. So I'm going to negate all of this. In parentheses, that's important. So after we add 1 and flip it, we're going to negate it. That's our rotation. So here was our vector, 1, 1, that we applied. Here is our rotation. And now we have to undo the vector we did, right? Because we slid everything over to make it easy to do our rotation, right? Just flip them and negate. And now we have to slide it back. What's the vector I'm going to use to slide it back? Negative 1, negative 1. So when I do that, I'm going to subtract 1. What's y plus 1 minus 1? Just y. Y plus 1 minus 1. Y. Negative quantity of x plus 1 minus 1 is going to be this. Minus 1 on the outside. And that's the rule. First we added 1 to slide it. Then we flipped the x and the y and negated this guy to rotate it. Then we subtracted 1 to undo that slide we did earlier. And that should get us the correct answer. If you got about 50% of that, that's great. We're going to go back and get the rest of the 50 in a second. Let's look at b. b is negative 1, 2, 3, 4, 5, 6. Up 3. b prime, after we've applied all this crap, should be 1, 2, 3, 4, 5 to the left, and 1, 2, 3, 4, 5, 6 down. Everybody cool with those coordinates? All right, let's see if our rule actually works. First, we add 1 to the x and the y. So let's do that. Here's negative 6, 3. After we add 1 to the x and the y, what do we end up with? Negative 5, 4. Then we rotate. Remember our rotation, we switch the x and the y's because what was x now becomes y, right? What was horizontal now it becomes vertical. So we flip them. And then we did one extra step. We negated this guy, right? We negated the right side. And the reason we do that is because we change this side when we rotate in this direction. We cool with that? So we get 4, positive 5. Now we're supposed to subtract 1. So we subtract 1 and we get 3, negative 6. Why didn't this work? I'm sorry, not 3, negative 6. 3, 4. Why didn't this work? This was on purpose. Who remembers from Friday? No, we did move it back. Who remembers from Friday?
Oh, didn't we have to like?
Who remembers from Friday? Why didn't this work? This is the mistake every single person is going to make tomorrow. Which is why I made it now, so you can learn from it. It's almost like you took the quiz, made the mistake, and you're learning from it. I'm making it for you right now, so you took a pre-quiz and you're going to figure it out. What is it?
Because you're moving the previous thing that you used to rotate.
Sort of. Let me translate. We move from R to the origin. That's not what we're doing. We want to move the origin to R.
Oh.
So we're going to start out subtracting 1. Then we're going to flip and negate. And then we're going to do what to undo that? Add 1.
I'm not gonna remember.
We are moving the origin to R. Why are we doing that? Because we're moving the axis down there. That's the idea. We're recentering our origin. Just like we did with our rotations. Or not our rotations, our reflections. Where are they? Just like we did here. We recentered our origin. We treated it just like it was there, and then we moved. Same thing here. Where'd you go? Where'd you go? Where'd you go? We're treating it like that's the origin. And the way we do that is we move it down. You're moving the origin to your center of rotation. This was traumatic, which means you'll probably remember it. Psychological scarring is a valid form of education. We move from here to here. We're moving the origin. Do we understand that? The most common mistake is to do it the opposite way. Let's check our work. We start out with negative 6, 3. We're going to move the origin to here. So we're applying the vector negative 1, negative 1. So we get negative 7, positive 2. Then we change them. And then we negate 1. 2, 7. Then what are we supposed to do? No one's paying attention right now. What do we do? We negate both and then do what?
Rotate it. Yeah, we did just rotate it.
What you're saying.
There's, add one to. You act like I'm gonna figure this out.
Where is it? What's the problem? I know.
We have another problem.
You made the positive. Looks like you made negative.
What's the mistake?
7 to 15.
Why?
Because you're not supposed to flip it. No.
Are we supposed to flip it and change it? Right? Why not? What? Switch the 2? What do you mean switch the 2? Change the sign of the 2, not the 7. Why are we doing that? Change this one. This side gets changed. What was here gets changed. So now we've got negative 2 comma 7. And then what are we supposed to do? Add 1? We're not there. Where's the problem? What's the issue? What's the issue? We went from here to here and that didn't work. Went from here to here. Why didn't this work? You are all being lazy. I just dropped my pen. Anyone? What's my first rule? Trust no one. Set up or be funny is really my first rule. You're right. What's going on here? Why isn't this working? Right, but what did we not do right? Jess? What do you mean I did the other part of the rule?
Like the negative in the thing, x minus 1 plus 1 to the 7.
Let it come in accurate now.
You're
I have no idea what's going on.
right, but I don't think you know how to explain it.
You should still be -7
Why?
because we changed the other one instead, and then we just kept the 7 after we figured them out.
All right, so here we are, -6, 3. Kodo, what do I do first to the -6, 3?
Save us. Come on, say it.
Subtract 1,
He's disappointed in us.
and I'm here. Then what? Flip it,
Advanced. He's smarter than you.
and then what?
You change the 2 to a -2.
Okay, I'm here. And then what?
Save us, please.
Then
Make
you,
7. Alright, we're gonna do a wait
then
until
you
we
add
solve this.
1.
No, Coda, don't solve this. I want to.
Why are we off?
Come on.
I'll give you self-development for the rule for the quiz. It won't. It'll be optional.
Can we work in partners?
I'd hope
No.
I was gonna help Aiden.
Carly or working for
He was gonna help Aiden. Yeah, he's confused, but I
I feel like I'm in ag right now. No idea what's going on.
Done.
You can read my mind. It's crazy stuff.
Later.
I feel like Dan.
Also give self-development for number 12 if you get all of that.
I feel like Dan White. I know my phone today. It's not funny. You got it at home.